Welcome to the Veritas Forum, engaging university students and faculty in discussions about life's hardest questions and the relevance of Jesus Christ to all of life.
Okay, so I'd like to start with two stories, and these are not just any old stories, they're funny stories. Okay? So the first one is about a guy named Karl Barth, who's one of the great theologians of the last century. So the story goes like this. After the service in the parish church, where Barth had been preaching one Sunday, he was met at the door by a man who greeted him with these words: "Professor Barth, thank you for your sermon. I'm an astronomer, you know, and as far as I am concerned, the whole of Christianity can be summed up by saying, do unto others as you would have others do unto you." Barth replied, "Well, I am just a humble theologian, and as far as I am concerned, the whole of astronomy can be summed up by saying, twinkle, twinkle, little star, how I wonder what you are." As a practicing Christian and a practicing physicist and astronomer, I just find this story hilarious. I'm glad you laughed. But it has a serious side too, because what it points out to me is it's very easy and very tempting actually to oversimplify, and especially with regard to subjects like science and religion, which are enormous subjects with contributions from brilliant people through centuries and even millennia. And I think all of us who are not experts in science or theology or both would do well to kind of tread carefully when we bring ourselves to this subject. And certainly I found it a pretty daunting task as I sort of put together my thoughts for this talk. The second anecdote is a little bit more local. It's actually a UCI anecdote. It has to do with Peter Dvorak, who's actually the chair of physics and astronomy here. When I was a junior professor, just got here to UCI some years ago, I was talking to him about teaching. And he told me this story about how he had taught Physics 3, and he was writing a final exam for it. So many of you probably know what Physics 3 is. Physics 3 is introductory physics for bio-sci majors largely. And so Peter said, okay, what do I want students to get from this? In fact, I'd like them to learn facts. I'd like them to learn concepts. But really what I'd like them to know is to know what they know and know what they don't know. Okay? Because if I have a doctor, they can look up stuff if they don't know it. But if they think they know something they don't really know, then we're really in trouble. So he said, okay, so what I'm going to do is I'm going to write my final exam like this. So it's multiple choice. We'll give 1 point for right answers, but minus 1 point for all the wrong answers. Okay? So he did this, and I want you to guess, what do you think the average was on this final exam? 3, okay. That's out of 100. So what do you think the average was? 50, okay. Okay, so here's the answer. Apparently there was a lot of this going on. Well, I haven't picked C in a while. And the average score was minus 20 out of 100. And the most amazing thing was some guy overslept, missed the final exam, and so got a 0 and got a B plus because he was So again, this is fun, this is physics humor, this is funny. But it has a serious side, which is, honestly, we all like to know the answers, we all like to think that we know the answers. But there are cases when the right thing to say is just, I don't know, okay? When you say I don't know, it doesn't mean that you don't care what the truth is. It doesn't mean that you think the truth is just relative. It doesn't mean, I have my truth, you have your truth, someone else has their truth. In fact, what I found is that among people of faith and scientists, a very common trait they have is they actually do believe, they do have faith that there is a truth out there waiting to be found. Whether they find it or not is a different question. But the fact is that sometimes we have limited knowledge, either we as one person or we as the human race. And in that case, we need to be ready to say, I don't know. And I think you'll actually see that I say that here a number of times in this talk. Okay, now given what we do know, however, is it the case then that science points toward atheism? If you look at history, recent history, or even not so recent history, you have to come to the conclusion that science is amazing. It's staggeringly effective, and the results are just indisputably amazing. People probably would say that science is the intellectual achievement of the last few hundred years, the last half a millennium. And this has led to some people thinking that science is really the primary, or maybe the only way to knowledge. In its extreme forms, this is sometimes called scientism. And I can't do better than to quote Bertrand Russell, who eloquently explained kind of this way of thinking about things. He said, while it is true that science cannot decide questions of value, that is because they cannot be intellectually decided at all and lie outside the realm of truth and falsehood. Whatever knowledge is attainable must be attained by scientific methods, and what science cannot discover, mankind cannot know. Now, if you are like me, a scientist, and you hear this, your first reaction is, this is a great worldview. Okay? This is right. Everybody should have this worldview, and we should all be, doubling the NSF's budget. We should all be hiring more physics professors at UCI. It's just a way to get anywhere. Okay? But if you think about this a little further, you start seeing holes in this argument. First, something that people often latch on to is this last statement again: what science cannot discover, mankind cannot know. If you think about that a little bit, that's not really a scientific statement. And so, okay, if it's true, then we can't know that it's true. And so it leads to one of these conundrums where it's kind of like the statement, this statement is false. It leads to some kind of paradox. More important than that, I think many of us would say there are non-scientific truths out there. Think, for example, of the very famous statement, we take these truths to be self-evident that all men are created equal. Okay? I think everyone here would acknowledge that's true, and yet that's not a scientific statement. And even more important than that, I would say, is what Bertrand Russell does acknowledge right at the top there, that science cannot decide questions of value. You have topics like areas of interest, of study, law, ethics, philosophy, art, humanities, general humanities, literature, where we have people studying those on this campus and every other university campus, and that's a very good thing, and they're not amenable to scientific sense. Science cannot tell you, what the correct policy is for measles vaccinations in Orange County. It cannot tell you which video is going to go viral tomorrow. It cannot tell you who you should marry or whether you should break up with your girlfriend or boyfriend tomorrow. There's all sorts of things that are very important, and yet they're outside the realm of science. Science has limitations. And I think all of us, even we physics professors, realize that. So, of course, although science is limited, it does tell us a lot about a lot of things. So what does science tell us? Let me tell you about just a very small part of what science tells us, which is the part that I work on and that excites me a great deal. So let me start with, what does excite me a great deal? Basically, as was said in the introduction, I work on the very largest and the very smallest things in the universe. Okay? And it's beautifully summed up, this philosophy, in this cartoon. Here you have two scientists walking away from a telescope, and one of them says to the other, I'll be working on the largest and smallest object in the universe, superclusters and neutrinos. I'd like you to handle everything in between. So that is pretty much my philosophy in my work. And let me try to explain why that's an interesting way to look at things. So all of you know, even those who aren't in physics right now, that if you start talking about what is the world made out of, you start at maybe at the level of atoms. Right? You know there's atoms, and there are electrons whizzing around nuclei. We also know that the nuclei are made out of protons and neutrons, and we even know that actually the protons and neutrons are made out of things called quarks. Okay, that's pretty much established scientific fact now. And we're probing deeper and deeper into this all the time, but this is already getting down to very, very small length scales. At the other side, the large frontier, as you know, we live in a solar system. Here's the sun with a bunch of planets. You see that it's not really drawn to scale, because if it was like this, we would all burn to death instantly. But you get the picture, right? There's also Pluto out there, so there's a little obsolete. But anyway, we now know that this is not just the only thing in the universe. There's actually a galaxy which we're a part of. If you look way out here, there's this little yellow sun thing. That's one star in that galaxy. And we also know that the galaxies come in clusters of galaxies, and so on, until you get to the biggest thing of all, which is the universe as a whole, and that's the study of cosmology. So what's interesting about this? What's interesting is that now these fields have become so mature that the knowledge of each of them is encapsulated in something called the standard model. So on this one side, we have cosmology, and there's a standard model of cosmology, and it tells us that the universe is made out of 68% dark energy, this big pinkish part of the pie, 27% dark matter, the blue part, and then 5% ordinary matter. Okay? On the other side, the small side, we have particle physics, and there's a standard model of particle physics. And through an incredible array of experiments and observations, we now know that there are 17 kinds of particles in the world. There were 16 up until 3 years ago, and then just very recently, that last one over there, the Higgs boson, has been discovered and added on to. So, this is great, and both of these fields have a lot going for them. Where things get really interesting is when you try to put them together, because what you find out is that that entire body of knowledge, those 17 particles over there, all go under the category of ordinary matter. Okay? Which means that despite our best efforts so far, we have no clue what 95% of the universe is made of. And this is, every day I wake up, and this is the fact I confront in my work. 95% of the universe is made of. It's a very humbling experience. At the same time, it's enormously exciting because it tells you there are worlds out there to discover. Just like in the 1500s when people were discovering continents and things, the same thing here. There's 95% of the universe out there to find. Now, right now, we know much more about what dark matter and dark energy aren't than we do about what they are. And actually, to be totally frank, we don't know a whole lot about what they aren't either. So there's a lot to learn. Okay, well, an interesting question then is, what do we make of our ignorance? What do we make of the fact that we don't know about everything in the universe? Sometimes in thinking about science and religion, people assume that the role of religion is to explain natural phenomena. This is sometimes called the God of the Gaps viewpoint. It's something that seems to be quite commonly held, but I don't know any religious scientists who actually think about things this way. When, for example, Stephen Hawking says that he has a mechanism for explaining the beginning of the universe, and therefore what need is there for a God, he's talking about a God of the gaps. Let me give you another example, which is up here on the slide. This is a recent issue of Physics Today. So this is a praise magazine for physicists in the United States. C.N. Yang, a great Nobel Prize winner, wrote an article about James Clerk Maxwell. Maxwell, you probably know, is famous for having equations, okay? Maxwell's equations. And what they did is they unified our understanding of electricity, magnetism, visible light, X-rays, radio waves, microwaves. All these things are now understood as coming out of one core phenomenon. It's an incredible thing that he did. And so C.N. Yang reviewed this work and then went on to say, Maxwell was a religious person. I wonder whether after this momentous discovery of his equations, he had in his prayers asked for God's forgiveness for revealing one of his greatest secrets. I actually don't know Professor Yang very well, but he may be joking. But this is probably the last thing Maxwell would have thought about. Maxwell was a devout believer. He was someone who memorized large chunks of the Bible. By one account, he had memorized all the Psalms. When he was young, he wrote back from Cambridge University to his parents saying that he was going to pursue something that would glorify God. And later on, as he got older in life, this is what he said. I think men of science, as well as other men, need to learn from Christ. And I think Christians, whose minds are scientific, are bound to study science that their view of the glory of God may be as extensive as their being is capable. What I think he's saying here brings to my mind something that may be a little old for your generation, but there's a movie called Chariots of Fire. Has a nice theme song. And in it, there's this guy who's a very fast runner, a sprinter in the Olympics. And he says, God made me fast. And when I run, I feel his pleasure. I think Maxwell is saying here something very similar. God made Maxwell a physics genius, and when he uncovered the laws of nature, he felt God's pleasure also. And that's more close to the sort of view of science and religion that many religious scientists I know have. Now, if we avoid God of the gaps sort of idea, what other options are there? Another very well-known possibility is that science and religion just simply don't intersect. And a very famous formulation of this is by the late Harvard professor Stephen Jay Gould, who said the following: the net of science covers the empirical universe. What is it made of? Fact. And why does it work that way? Theory. The net of religion stands over questions of moral meaning and value. These two magisteria do not overlap. And so this became known as the non-overlapping magisteria viewpoint. This, I think, has been criticized by almost everybody, from theologians to pastors to new atheists like Richard Dawkins. Is in fact one of the few things that everyone kind of agrees on that they don't like. In fact, I also disagree with it. For me, as I assume for many of these critics, the problem is that religious worldviews, when taken seriously, have implications for how the world looks, what it's made out of. And conversely, scientific work, scientific results, have implications for religious beliefs, and they should do that. This viewpoint, I think, is shared by many people, and I'll just give you one example. This is Charles Towns here at the bottom, who very sadly just passed away a few days ago at the age of 99, but he's a Christian, and he was the inventor of the laser, basically, the laser. And he says, understanding the order of the universe and understanding the purpose of the universe are not identical, but they are not very far apart. And I think there's a lot of wisdom in that statement. Okay, so does science point toward atheism? Let me draw from my own research a bit to address this question. And before I do this, I want to be very clear. We are not now dealing in the realm of proofs. Okay? I am not setting out to prove atheism. I am not setting out to prove theism. I think proofs are not the way to think about this sort of topic. Rather, what we're doing is presenting and gathering evidence. You might be surprised to hear from me, a scientist, that actually the first topic here would be beauty. Beauty and science. Science actually relies greatly on beauty. What exactly beauty is another question. You might actually think of scientists as spending much of their undergraduate careers, their graduate careers, their years as postdoctoral scholars, and even their years as faculty, trying to develop a sense of what beauty in science is. Okay, so this is not something that I'm going to be able to just tell you in one sentence what it is, just like beauty and anything else. But other words that are sometimes used for beauty are symmetry, elegance, and order. And let me try to use the concept of symmetry to get across at least some of what beauty is. So I've drawn up here two shapes. Okay, there's one on the there's one on the left and there's one on the right. Okay, what I want you to do is look at them and tell me which one you think is more beautiful. Okay, so let's start with the one on your left. How many people say that one's the more beautiful one? Okay, good. And how many people think that ugly blob on the right is? Okay, some of you still do. Okay, but most of us actually think that the circle is the more beautiful one. And the way we in physics understand that is that it has more symmetry. It looks the same if you rotate it. Okay? And so that's a way to sort of quantify a beautiful object or a beautiful concept. Now let me take a little bit of a detour and quickly wrap this together. There are actually four forces of nature that are known. There's gravity, which everybody here knows about. This is something you learn about before you can even talk, right? There's electromagnetism, which is electricity and magnetism, and yet again, that's something we all know about. You see it in lightning, for example. There's two more, which are a little bit more esoteric. There's a strong force, which is the force that pulls the protons and the neutrons together in a nucleus. Okay? Otherwise, the protons would just fly apart because they're electromagnetically repelling. And finally, there's the weak force, which is more esoteric still probably, but if you take a neutron out of that nucleus and just leave it sitting there in empty space, after about 15 minutes, it will disintegrate and it will turn into an electron and a proton and another particle called an antineutrino. But that's done through the weak force. Okay? Now these forces, as you can tell, are incredibly different looking. Gravity and electromagnetism are sort of common in everyday life. Strong and weak forces are something you might not have heard about. But electromagnetism, you can have things repel or attract. Gravity, everything is always attracting, right? So there's a lot of differences. But the amazing thing is that symmetries actually explain the behavior of all of these forces. How does this work? Well, it's a little mathematical, but basically what happens is there's a symmetry in your theory, which is very much like the symmetry of rotating a circle. And it implies, in one case, a massless graviton, which is something that mediates the gravitational force. And that implies that the law of gravity goes as 1 over r squared, something that's 2 times as far apart as 1/4 of the force. So it's a very famous law of gravity from Newton. Turns out the same symmetry, same kind of symmetry, implies a massless photon, the force carrier of electromagnetism, which also tells you you have a 1 over r squared law of electromagnetism. And amazingly, the strong and the weak forces, which are totally different looking, have exactly the same sort of explanation in symmetry, although it's a little bit more subtle. To me, this brings up the question, why is the universe so beautiful? Why is it so elegant? Why is it so ordered? And in some sense, even a more amazing question is, why are we able to comprehend it? This is not just me talking. People that are much more famous than me have had these exact same thoughts through the ages. Eugene Wigner called it the unreasonable effectiveness of mathematics in the natural sciences. Albert Einstein, in his inimitable way, beautifully said it in this way: the most incomprehensible thing about the universe is that it is comprehensible. Now, how would this happen? It would seem to me to go well beyond natural explanations. Now, there's no evolutionary advantage to knowing quantum field theory, to knowing a lot about Lie algebras and mathematical symmetries. Maybe there's these things that emerge as side benefits to being able to track a rock or a sphere or something like that. I honestly don't know, and that's a very sincere question. I'd be fascinated to know. But for me, all these results do not point toward atheism, but rather lend credence to this idea that there is a creator with immense intelligence who created an ordered universe and created us to live in it and to explore it. Now, what I've talked about so far, beauty has drawn mainly on the small side of things. What about the large side of things? As I talked about, I also study the largest things in the universe. So let's discuss this. Our understanding of how the universe has evolved has changed dramatically in the last 100 years. Previous to that, there was the Newtonian way of thinking, where space and time are just the fixed state at which things act. Okay, so you want to figure out how a ball moves or something like that, you set up a grid. Okay? There's a graph paper sort of grid, and you label things with coordinates x, y, and z, and maybe time. And then things roll and things move. Okay? It just seems completely obvious that the space is just the stage, and then things happen on the stage. Okay? The stage doesn't become inactive. Turns out, however, that it does. And almost exactly 100 years ago, Albert Einstein showed that, in fact, first of all, space and time are not separate. There's something called space-time. And second of all, it is an actor. It does things. It can curve, it can shrink, it can expand. It can push things around, and those things can push space-time. Okay? So it's an amazing achievement, which is a general relativity. Now, just because space can expand and contract doesn't mean that it does, but shortly after that, and then through an incredible array of experiments and observations, we've now figured out that, in fact, the universe does make use of this, and in fact, it is expanding. So here's a picture of trying to convey this idea of an expanding universe. So if you come this way toward me, you're going to the future, the sort of galaxies on this balloon are getting farther and farther apart, things expanding, getting farther apart. But of course, if you play the movie backwards, you go back in time, and then the universe gets smaller and smaller and smaller, and you ultimately get to a point where space was extremely small and where time began. Now, again, this has, to be fair, we want to say that the Big Bang is actually a topic of current research. Okay, there are lots of interesting questions about what really happened there at the Big Bang. There are ideas called inflation that are actually quite well motivated, although still speculative, about what's really going on there. Inflation posits that there was this incredible expansion very early in the universe's history. But from my perspective, again, the fact that science has come around to a view that is roughly in keeping with the biblical story of creation of heaven and earth does not point to atheism, and instead looks an awful lot like a creation event and points toward a creator. Okay, finally is the topic called fine-tuning. This is maybe the most esoteric of all, but please try to stay with me. I'll try to give it a good try. The fundamental concepts of nature have to be incredibly fine-tuned to show that life, to make life exist. Okay, so what am I talking about? I'm talking about things like the speed of light, Planck's constant. You can take these things and form dimensionless combinations of them. And if you jiggle those even a little bit, you would find that life just can't exist. Basic things, like there would be no planets, there would be no galaxies, there would be only hydrogen and helium in the world, something like that. Okay? Now this fine-tuning has been documented in books and articles. Let me just give you one very small example, which is about the amount of dark energy. I mentioned previously that we now know that there's about 68% of the universe is dark energy. It turns out that given what we know, there should be a lot more. Okay? In fact, a lot more. We expect actually something like 10 to the 120th power more dark energy than there is. Basically, every particle we know about comes with some dark energy. And somehow all these contributions have magically canceled each other off to leave what's observed. And so, to try to get this across, I've written for you 220-digit numbers. And the idea is that somehow these two numbers have conspired so that they're exactly the same for the first 119 digits, and they differ only in the last one, so that when you have one minus the other one, you get one left over. And that's consistent with observations. Okay? Another way to say it is, if I ask you for a 120-digit number, just write one down, and I ask you over there for 130 digits to write one down, and you wrote them down, what's happened here in the universe is magically you've written down the exact same 120-digit number except for the last digit. Okay. Or another way to say it is, let's say when you walked into this lecture hall this evening, you saw a pen standing, or a pencil standing on its tip, and somehow through the entire time I've been talking, 20, 30 minutes, it just stood there. Okay? That's an incredible fine-tuning problem. How could that be? Now, this is a serious problem. Okay, this is something. There's many forms of this. We, as the world, for example, have spent $10 billion building something called the Large Hadron Collider in Switzerland to investigate yet another fine-tuning problem. And I think it's widely acknowledged that this is a serious problem with our understanding of fundamental physics. It's not a small problem either. You might say, well, okay, you're kind of requiring life. What is life? Life could be not carbon-based, it could be silicon-based or something like that. But the fact is, you could require very, very general conditions. For example, you could simply require that the universe lasts for more than 1 second, okay, which would seem to be a pretty minimal requirement for life. And that would already be an immense fine-tuning problem. Okay, so what are the responses to this problem? The first one is, well, it's just chance. These numbers had to be something. They're there, that's what they are. That would be equivalent of, like, you go to Las Vegas during spring break, and someone's dealing out your hand, and 100 times in a row you get 4 aces. Okay? And the casino comes over and says, think you're cheating, none, it's just chance, It had to be something. I got cards and there's just 100 straight for aces. This is not a response that anyone would consider a solution. The second possibility is something called the multiverse, which is that we don't live in the only universe. There are other universes out there. And this is, of course, quite speculative, but the idea would be then that, well, if you have, a huge number of universes, almost some of them, there's going to be life. There's going to be the right parameters, just by accident, there's going to be the right one. And we happen to live in one of those, which isn't surprising because life had to be possible for us to observe this universe. This one has got a lot of press. It's got a lot of problems, too. One of them is that it's not at all clear what an observable prediction of another universe is, right? If you see something from somewhere, that's probably part of your universe. So what's the evidence that there's another one? And there are other problems too. I probably shouldn't get into them now, but once you open this Pandora's box of having lots of universes, actually, typically, lots of them can have life. And you have to ask then, is it probable that I live not just in one that has life, but the one that we see right now? And a lot of multiverse theories actually predict that no, our universe is very, very weird for one that has life in it. Anyway, that's something that is on the table. A lot of physicists find it completely repulsive and don't even consider it science. It's a very controversial idea. Third possibility is just simply, well, there are these numbers, and the creator who built the universe had life in mind. Fourth possibility is that this fine-tuning problem is a bit of a mirage, and when we get smarter, we will have beautiful and yet to be discovered laws of nature, which we will discover, and they will explain the fine-tuning. So, for example, if you saw this pencil over here standing on its tip like I was talking about, but then you studied the problem carefully, and you came up very close, and you saw that actually someone had put a little drop of crazy glue there at the bottom, and then stuck the pencil on there. Then it wouldn't be so puzzling anymore, right? And so it's possible that there is some explanation like that. It would be a theory that is way, I can't even say way, enough times beyond what we know now. Okay, it's unbelievable to think that that could happen. But of course, science progresses unbelievably sometimes, and so that is a possibility. For me, if that actually happens, then this would probably go into the beauty category. We would have a theory of such great beauty that it would yet more convince me that there was some mind behind it. Okay, so I'm getting the few minutes left signal, so let me try to finish up. I would go to work every day and enjoy finding out about the mysteries of the universe. As a Christian, I don't really feel like my scientific work is a threat to my faith. Rather, for me, as I've shared, modern science does not point toward atheism. In fact, it's consistent with a belief in a God who created the universe and physical laws that govern it. Contrary to what some of you might be led to believe, there are actually many scientists like me who take the same approach. Some are like me, who grew up in sort of Christian settings and have always viewed their work in science in this sort of context. Others, a prominent example is Francis Collins, who is the current director of the NIH, former head of the Human Genome Project, became Christians after they were already scientists. And why did they do that? Because Christianity helped them make sense of the rest of their life experiences. That brings me actually to one last point, or one very important point. Although I tried to stay on topic here and talked about the relationship of science and faith and how they play out in my life and my perspective, anyone who's read the Bible knows that it's not so concerned with teaching you science. It's more concerned with your relationship with God. For me, what is truly amazing about the Christian faith is the incredible idea that the God who made the universe, from quarks to galaxies, was also loving enough to care for the people in it, to be born as a human being and suffer and die on a cross in the person of Jesus, and to bring forgiveness and new life to broken people. A poem written thousands of years ago and recorded in the Bible expresses this better than I ever could. It says, "When I consider your heavens, the work of your fingers, the moon and the stars, which you have set in place, what is mankind that you are mindful of them? human beings and took care of them. This is perhaps the most amazing thing to me and one of the deepest mysteries of all. Thank you.
This is, I think, the fun and exciting part. This is where we get to ask Jonathan all of our interesting questions. The nice thing is, moderator, I get to ask the first few. But for the people in the audience, I hope that you can text in questions. I've already got a couple on my phone, so I'll be pulling out my phone periodically to look at those. We'll go to some of the text questions.
You're not just reading your email.
I'm not just reading my email when I look at my phone, trust me. I may do that too, but so there's the information for texting your questions. We also encourage live questions. Just be aware we don't have microphones in the audience. So you're going to have to talk really loud, mainly so I can hear. I'll repeat your question, because facing me I should be able to hear it, but the people behind you may not. So I'll kind of alternate between the audience and the text questions, seeing how it goes. But I do want to start off with, for Jonathan, you've talked to us a lot about your science and some about your faith, and I think a big question people might have is, has there ever been a time in your life when you seriously doubted either the existence of God or the story of Christianity? And if so, how did you process those doubts?
Okay, so that's a very good question. Can you hear me? No?
Yes.
I know that there.
No, I think that's a thumbs up. Ooh.
Oh, okay, good. So maybe I can just start by saying a little bit about my upbringing. I already mentioned that I grew up in a Christian environment, a Christian home. It was also a very academic home. My parents, on the block I found out later, people were telling me that my parents were a rocket scientist and a brain surgeon. And it wasn't quite true, but it was not too far from the truth either. And so I always sort of grew up in an academic and Christian environment. And so in terms of that, I think I didn't have very many serious doubts growing up. Of course, that's not the only way one has doubts. And so as I got to college, graduate school, I think my faith, I wouldn't say I lost faith, but I would say my faith sort of dimmed. It was a bit of a valley. And it wasn't until later on, and basically what happened was I decided sort of that faith was not quite consistent with some of the things I was learning, and also just that I could carry on with my faith without any other people. And so lost community. And I think that was actually quite a rash thought. And later on, I sort of regained community and came back from that.
Okay, excellent. And as I ask the questions, as you do, and as Jonathan answers them, again, if you think immediately of follow-up ones, that's a good time to text it in, or if you're doing it live, we can follow up with that. I do want to kind of build on that question a little bit. I think a challenging, let's start with kind of a big what if. What would it take, do you think, if anything, to turn you into either an atheist or to completely change to a whole new religion?
That's a big
That's just to give you a sense of how far you can stretch your questions.
I think the one thing that my faith does hang on is the life of Jesus and his resurrection. And so I think it's pretty well established that Jesus was a real person, both from biblical accounts, but even extra biblical accounts. And so don't think that happened. There was proof that the resurrection was just simply fabricated, then that would have a serious impact on my faith. Now, how could this happen? It could happen through, I guess, archaeological or textual revolutions. Sometimes people have asked me, what would happen to your faith if some other, race of people were discovered on some other planet or something? And that's a whole other what if. But if we found some other people somewhere, it turns out they were much more technologically advanced than us, and they had the ability to transport people like in Star Trek. And it turns out 2,000 years ago, they were a little fun joke. They were able to transport this guy out of his cave. That would put a serious dent in my faith.
Well, I have to say, having been on Ancient Aliens heavily, I can say that probably didn't happen. No evidence for Ancient Aliens messing with that. And then one other question I want to lead in with, and then we'll go to the live ones and the text ones. And this is just, again, from the science side. Obviously, you're a cosmologist, you're a physicist, your talk focused most on the cosmology aspects of science and faith. But I think a big question for everyone, and I'm sure more of it will come up, is the idea of evolution. And often in the public presentation, these are presented as what might be strongly stated as mutually exclusive worldviews, Christianity and evolution. Not everybody feels that way, but it's often the way it's presented, and almost sometimes it's a litmus test. I want to ask you, do you believe that you would have to reject evolutionary theory to be a Christian?
So I don't believe that. And I think that, well, first of all, I think evolution is sort of the core of many fields of study. So just as quantum mechanics is the core of physics, I think evolution is assumed by many and is a sort of part of working knowledge in the biological fields. I see the evidence for that being very strong. I also don't see that as a challenge to my faith, because as I've shown, through my views about physical sciences, I see God sort of working in the laws that He's providing. And so, from my perspective, and of course I'm much more confident about things on the physical science side than the biological, but from my perspective, the similar sort of application to that would be that evolution is consistent with my faith.
Okay, excellent. We do have some text questions already. In fact, people were bold and texted them during the talk. But before going to those, I wanted to see, are there people with a burning live question? Let's go there first. Okay, we'll start in the middle.
I just had a quick question, because you said obviously you think evolution, doesn't necessarily have to be contradicted by religion. So do you believe in it fully? Do you believe that we did come from chimpanzees? What is just your personal philosophy on it as a physicist and an astronomer?
Okay, I'll repeat the questions, or do you want to repeat them?
No, go ahead.
Okay, so the main core of that question, if you didn't hear it, was following up on the evolution question. What's Jonathan's views on, did we come from a chimpanzee or not, or what does he take out of evolution? Would that be a fair?
Yeah.
Mm-hmm.
Okay.
So I pretty much believe in the core tenets of evolution. For me, the weaknesses of evolution are not in what people were talking about, but in questions of could the rate of evolution be as fast as it used to be, and especially in the very beginning, whether life was created out of inorganic things at the beginning. Those are sort of, to me, the weakest points. But in terms of the process of evolution, I see it as what's often called theistic evolution. I see it as God working through the evolutionary process.
Okay. There was one other question over here. We'll go there, yes?
Yeah, I have one over here. So I was just wondering, when you look at the history of physics, in the 18th century, it seemed pretty clear that everything was pointing in the other way, towards atheism. You had kind of a deterministic understanding of the way the world works. There is no room for free will. And yet, all of a sudden, when modern physics came around, everything just changed. So I guess my question is, with that in mind, how much confidence do you think we can have in our understanding about God through what we know now, when we still don't have the full theory of everything?
Okay, so just if you didn't hear it, the question focuses on when science, maybe back in the 18th century, the focus was everything is deterministic, no room for free will, pointing more strongly perhaps towards atheism. Then we move into a modern era. We have a whole new paradigm, quantum mechanics, relativity. So given the changes in science, how confident might you be in relying on science as pointing to or not to a God? Is that a fair?
So I think that's a very good question. I would first like to just emphasize what you said, because I think there's some people who would say, this is actually the wrong time to be a believer in anything. And there's others who would say that, in fact, the recent developments in physics encourage you to believe in a creator through some of the arguments that I mentioned. And I sort of swing toward the second. Before that, you had a completely deterministic universe. You had Newtonian laws, the sort of advent of quantum mechanics, where there's probabilities. And I'm not saying that I understand how free will interacts with quantum mechanics and wave functions and things like that, but it opens the possibility for free will. And so I actually do think that the developments of the last 100 years have maybe not seeped into everyone's understanding of the physics implications for religion. That said, you have a very good point. Okay, so now you say things are maybe pointing more toward religion. About 100 years from now, maybe it points back the other way. And to that, I guess I can only say that we can only deal with what we know now, right? We're sort of confined to live at the present time. And so typically science doesn't swing wildly back and forth. It kind of goes in a direction and things get refined and better, but the old things still retain some sense of truth. Now another point though is, to be completely honest, nobody decides they're going to go to church one day because they wake up and they think, I don't know how the universe began. That's typically not the strong motivation. For some, maybe it is, but it's not. It's typically that they see, a life transformation in someone else, right? They somehow have community or some interaction. And so I think we can learn a lot from that. I would say there's a lot of evidence for God and the Creator from those sort of lines of evidence. And of course, those weren't what I talked about at all because the topic was more science and things. But I would not discount that at all. I think that's actually extremely important.
If it's a follow-up, I'd like to go there, or otherwise I have a text question.
Sort of a follow-up.
Let's go there then.
Okay. So, in that light, is the absolute truth ever available to science, or are we sort of hedging our bets about what we think?
So the question is the absolute truth ever available to science, or are we hedging our bets? And I'd like to put Jonathan a little bit more on the spot, if I may, and add a piece to your question. Is the absolute truth ever available to science, or is it even ever available to us through religion? Meaning, and you had alluded this into your talk, so I'm sort of encouraging you to expand on that. Where do you see our access to absolute truth, both through science and through faith? I know, we didn't practice this one, so it's totally on the spot.
I'm speculating here, but for me, I don't see the end of science coming anytime soon. There are some people who talk about the theory of everything and sort of think that we may be on the cusp of understanding everything. I think those people should look at the history. There were people who thought that 120 years ago also, and look at what we learned since then. So for me, it just seems incredibly unlikely that we're at the point where science will just be able to understand everything. For faith, there is a leap of faith, but there's also this rational component to it. So there, my answer has to be a little less, for some people, they have absolute certainty, I think, based on their faith, and that means something very real to them. But I don't want to give the impression that it's just simply a leap of faith. I think most people's faith is actually built on some rational understanding of things and is tested over time. And there's sort of a mix then of sort of rational thought and faith. So it's a slightly different answer than for the science question.
Okay. Excellent. I do want to go to one of our text questions, because I think this gets at something that was at the end of your talk, and again, pushes some of these boundaries, and I think it really gets to a little bit the science side. You talked about the resurrection of Jesus being central to the Christian faith, and the text question goes like this: the physical resurrection of Jesus is a foundational belief of Orthodox Christianity. As a scientist, do you believe in a literal bodily resurrection of Jesus? And the follow-up would be, if so, how do you make sense of that on a cellular level? And perhaps you will not answer yes, in which case you don't have to answer the follow-up question. So I've seen many different discussions of the resurrection of Jesus, whether it's literal bodily or others. So how would you like to go with that question?
Okay, so the quick answer is I do believe in literal bodily resurrection. This gets into the whole question of miracles, obviously. And so this is a long discussion we could have because it's very relevant to this whole idea of science and faith. but maybe we should postpone that for a second. What is this belief in the resurrection based on? It's based on certain things that I find remarkable in the accounts. Various things. The fact that it was seen by many people, crowds of people afterwards. The fact that the people discovered him were women. That's a very bad move if you're trying to pick up some ploy 2,000 years ago. You would not have women be the witnesses. So there's kind of circumstantial evidence like that. But of course, it all hangs together for me. Now, to get back to the question of miracles, this is a big question. Sophonism says, how can you believe in miracles when you have, natural laws? And my answer is that natural laws cannot, disprove a miracle. The whole point of miracles is that it's a violation of the natural law. And so it's really a question of historical evidence, of evidence in texts and things like that, eyewitness accounts. But okay, so there's more to discuss on that. So
Maybe we'll get a follow-up from the text or by in person. Any other burning in-person questions before I go back to our text? Yes?
So I'm not sure if this is the opposite of your talk, but you were arguing, it seemed, for deism, or rather the absence of atheism, and then now you're kind of advocating for Christianity. So I'm wondering how you go from deism, or rather the absence of atheism, to theistic Christian beliefs, and also the point that deism and so deism can be completely contradictory towards Christianity as well. So you have a God that's completely contradictory towards Christianity or every other religion on the planet.
Okay, so for those who didn't hear it, the question gets at perhaps a quick summary, different views and definitions of God. And in Jonathan's talk, maybe there's a sense at the beginning, early on, he's talking more about a deism or a deistic type of God. Maybe more simply just an absence of atheism without specifying what God is like or who God is, moving towards the end of the talk where he talks very specifically about Christianity. And the question is really just to have him comment on that thread and how he got to Christianity.
So we'll say there's a pretty big chasm between those two things.
Right. So with the huge difference, big chasm between those two ideas of God, where's that connection come to you?
So that's a very good point, and it's a bit conflated in the talk, so I agree with you. A lot of the things I mentioned are really evidence for theism, right, or for a creator. And getting from that point to actually the Christian God is, as you say, another step. For me, I can only say that the Christian story carries a lot of weight for me, and I tried to mention this at the end. The idea of God becoming incarnate, the idea of forgiveness, the idea that we are justified by works. These things are not common to all religions. The creation story, as told in Genesis, isn't common to all religions. And so for me, these are sort of the things that point me not just to theism in general, but to Christianity. And it's what can I say? I try to live out a Christian life, and what I see in Christianity works. So basically, at the bottom end of it, I find that Christian philosophy and the Christian sort of foundation is in concord with so many other things that I find that a very convincing realization.
I'll come back to you in one quick second, but I'm going to take my moderator prerogative for a follow-up. So would you say it's fair, Jonathan, from your presentation, that in the parts where you're implying science might point to a God, that does not necessarily apply to the parts where you're talking about Christianity, that for you, the leap to Christianity came from aspects that are not necessarily scientific?
Yes, although, like I say, for example, in particular cases like the origin of the universe, that one may be more specific to Christianity.
And now your follow-up.
So you seem to say that you're choosing Christianity because you like it, like you like certain aspects of it, generosity and other aspects. So what's to stop you from making your own religion, just tailoring something that is consistent, let's say, with deism, but is more personally tailored to your beliefs and what you want to see in some type of belief system?
Okay, so the follow-up question basically goes to Jonathan was talking about the aspects of Christianity that appealed to him and he liked. So what prevents him from tailoring and creating his own religion, starting maybe from deism and bringing in the elements of Christianity that he likes?
So I have to disagree.
Is that, that was the question, right?
Just like elements of whatever.
Yeah.
I have to disagree with you right at the beginning, where you say that you seem to just be preferring Christianity because you like it. That gets to a very general question. Do you just believe because it's a crutch, because it makes life easier for you? In the end of the day, I think it does, but not for the simple reason that it makes you happy, or that it just kind of is easier. I think something that's not appreciated very well by many people is that faith can make things a lot harder too. You read the book of Job, for example. You talk to someone who is a believer who doesn't hear God's voice when they think God should be guiding them. For these people, sometimes it'd be a lot easier if there was no God. And so it's not a matter of simply finding something that makes you happy. It's a matter of some deep-seated concordance between what you observe in the world, what happens in your life, and the teachings of a religion. And so all those things are actually what bring me to that.
I'd like to go to a text question. It kind of gets at this idea, I think, staying in this theme of, with the Christian particular view, and the Bible. So it's, I think, pretty clear, and you even alluded to it in your talk, that there are definitely things in the Bible that science effectively disproves. Given that there are these things that it disproves, what then is the motivation or justification in believing other stuff in the Bible about God that is not maybe necessarily related to science? Yeah, okay, so
I'll say it again.
it's a tricky one. So there are a bunch of things in the Bible that were basically proved to be wrong by science. And you even alluded this to your talk that the Bible is not necessarily teaching us science anyway. But given that, why do people still think the other stuff about God's reliable? So if there's stuff that science can prove is wrong, why would you believe the other stuff?
Well, here I guess I'd have to have a conversation with the anonymous.
So feel free to follow up on your text.
I don't think necessarily that I said that there are things in the Bible that have been proven to be wrong.
You may not have said that. The question added that, and I was just pointing to parts of your talk where you implied that the Bible isn't necessarily a science textbook. So what it says that looks like science may actually contradict actual science.
Okay, so there are things, for example, that people may have thought that the sun went around the earth, and then now we don't think that anymore. And people might have seen that as contradicting what it says in the Bible, whereas I would say that now with more science we have a better interpretation of the things we have in the Bible. I mean, one thing that's very important is that I think we have to realize that the Bible cannot be taken literally in the strict sense in all of its passages, right? It says things like Jesus says, "I am the door." I don't think he's the door. So there has to be some measure of interpretation, and there's all sorts of other reasons why most of us speak English. The Bible wasn't written in English. Right there, you've got some problems. So okay, so I think for me, it's important to realize that there is interpretation. There are parts of the Bible that are not to be taken literally in that sense. There's poetry, there's other sorts of literature in the Bible. And so that would be my answer.
Okay. If the person who texted that wants to follow up more, you can either retext or raise your hand. Are there any other live questions at the moment? Yes?
Aristotle's prime mover argument seems like a fairly reasonable logical explanation for why there must be some deity, or at least some deity to start the universe. What is the scientific evidence that many people champion to sort of accept and hold to an atheist worldview? If it seems to me that there's this fairly reasonable, logical proof for why there must be a deity.
Okay, so the question basically is asking, if you look at something like Aristotle's idea of a prime mover as a philosophical or logical proof for the existence of a deity, what might be the scientific evidence that atheists use to counter the argument that a deity must exist? Now, that's a trick question for you, Jonathan, because you're not an atheist. But
I think you're going to have to go with I don't know.
yeah, which was allowed by his talk. We established that at the beginning.
Yeah, I guess you'd have to talk more carefully with an atheist to get a good answer. Okay.
Just thought I'd ask.
Okay, thank you.
One of the other questions that just kind of recently came in on the text is, do you ever consider that God is in dark matter? I am intrigued at the concept of dark matter somehow having a creative power or role. Do you have an off-the-cuff response? Or do you have a serious response?
Well, what we understand of dark matter is not really something that God would be in.
Right.
Our current understanding of dark matter is it's very much like normal matter, except it doesn't shine. It doesn't couple to light. So while I said that we don't really understand what dark matter is, that's within the context of science. We do know that it does certain things, like it gravitates and it helps form galaxies and things like that. So it's a bit of a jump outside the scientific realm to start thinking of other things like that. I actually was at a conference recently and stayed in a hotel. I was having breakfast with some strangers, and they said, "What are you doing here?" I said, "Oh, I'm here at a conference talking about dark matter." And they said, "Oh, I don't hear about dark matter." I said, "Oh, okay." They said, "Dark matter is love." And, I didn't know what to say. I think maybe there's, I'm not trying to make fun of this, but all I'm trying to say is that when we talk about dark matter, we have a very specific sort of idea in terms of fields and particles in our theories. And so it's not really amenable to that sort of interpretation.
Okay. We are getting low on time, so I do want to, I have some text questions and some of my own, but I want to make sure we get any live questions that are still out there. So, yes.
So, what are your thoughts on heaven and hell? Are they like separate universes or states of mind, or the place where the soul is taken to once the body decays?
Okay, so the question is, getting us back across to the realm of miracles, a very good, interesting topic. What are Jonathan's thoughts on heaven and hell? Are they separate universes? Are they a place the soul goes to? What are your thoughts on that?
Well, so I have a lot of reservations about my understanding of the origin of the universe. The end of the universe is even more mysterious to me. Okay, so let me preface this by saying that. For me, heaven and hell aren't necessarily places. In the sort of, I don't think of hell as a place with fiery pitchforks and things like that. What I think of it as is a place with the absence of God, a distance from God. Whether it's people have talked about it being in a different dimension or being somewhere else, I really don't know. But for me, the essential thing of it is that it's heaven is a place where God is present. Hell is a place where God is.
Okay. I'll look for maybe one more live question and then do one more text question. Yes, up there in the middle.
Okay, so suppose an event happened that basically did violate what we understand as natural laws. What would determine whether or not it's a miracle or just that it indicates that we are some misunderstanding of how natural laws work?
It's a very good question. If you observe an event that appears to violate natural law, how can we tell if this is truly a miracle or an actual violation of natural law? Very, very relevant for those of you who are unaware to the history of UC Irvine with the whole discovery of neutrinos. But I will see where Jonathan wants to go with the question.
This is a tough one for me because I think it would depend on a case-by-case sort of basis. There are things that have been reported to happen which just contradict so many known laws and things that have been tested and tested over and over again that you would either put them in the category of just the experiment was wrong, or if you wanted to put them in the category of a miracle. Mike brings up this question of neutrino. That's a very interesting question. The idea there was that there were processes that happened, and you kind of had a choice. Either you violated conservation of energy, or you had a new particle. And in that way, it came down to be a new particle. And the sort of sacrosanct law of conservation of energy remained intact. So I think it kind of depends on a case-by-case basis. We have, encountered this sort of thing all the time in science, although the miracle aspect, of course, isn't the first thing people go to. But if you recall, just a few years ago, we had reports of faster than light neutrinos. And, that was seen by almost everybody immediately to be crazy because it contradicted so many of the other known facts. But it depends. I think it has to be a case-by-case.
Excellent. We are running low on time, and out of respect for that, I'm not actually going to go to some of the remaining text questions. These have been excellent questions. I think a great start to a wonderful conversation. It would be very exciting to continue it. I think these sort of conversations are very intellectually stimulating and something that should be a part of our university experience. So I'm very glad that Jonathan was willing to come out, share both his science and his thoughts with us. Before we applaud for him, as the speaker, he gets a chance for any final thoughts. So Jonathan, do you have any final thoughts you would like to share before we wrap up?
I think only to say that these kind of conversations we're having are fantastic. For me, they've been very challenging, maybe for some of you also. And I think my parting thought is, for many of you who are university students, this is a fantastic time to be asking questions like that. This is a place where there's diversity of every sort of kind, not just religious, ethnic, economic diversity, things like that. And my only thought would be to encourage you to go out, talk to other people, talk to people you don't normally talk to, and get to know them. You're at a stage in life where this is, believe me, a lot easier to do than later on. So I simply just want to leave you with that advice.
Okay, so I'd like to thank all of you for your participation, and let's thank Jonathan for his excellent presentation.
For more information about the Veritas Forum, including additional recordings and a calendar of upcoming events, please visit our website at veritas.org.